Okay, now let us see a problem on heat equation. So as I mentioned, the heat equation was dou u by dou t is equal to c square into dou square u by dou x square, and the solution is given to be uxt is equal to a into cos alpha x plus b into sin alpha x times e raised to minus alpha square c square t. And this is the case when the temperature changes, when temperature is expected to change with respect to time. If it is not changing with respect to time, the situation is called a steady state, and there we have an equation like uxt is equal to ax plus b. Now let us see a problem, a simple problem. This is the most simple problem in the case of heat equation. So suppose a rod of length L with insulated sides is initially at a uniform temperature U0. Its ends are suddenly cooled to a temperature 0 degree and are kept at that temperature. Find the temperature function. So here observe the data given. So first it is said that the sides are insulated. Of course, it's a common assumption made on the rod. And the important thing is that initially the rod is at uniform temperature U0. That means uniform temperature means temperature at every point is the same. It's a constant U0. Okay, so this U0 is the constant temperature at which every point is there at a time 0. So at every point of this rod at a time t equal to 0, the initial temperature is U0. It's a constant. So that is one of the conditions that is given in the problem. Okay, now then what information is given? Its ends are suddenly cooled to 0 degree and are kept at that temperature. Then what happens is, say suppose you can assume that this rod is kept at the room temperature. So if you just keep a rod, every point will be of the same temperature, and it will be usually the room temperature or slightly changed, okay, depending on the material. So then what we do is this left hand side and right hand side are kept at 0 degrees Celsius. Then what happens is immediately the left hand point will assume the temperature 0, and the right hand point, the right cross section, every point will assume the temperature 0. Okay, and we are keeping it at that temperature. That means U0t means at x equal to 0 the temperature is assumed to be 0 for every time t, and ULT is also 0 for every time t. Okay, that means ULT means the right hand side. The right hand side is also kept at the temperature 0. That means you are keeping an ice cube on the left side and right side so that the endpoints are at 0 degree, whereas the temperature of the points in between will slowly reduce. Okay, so we have to see the temperature distribution in such a situation. So we have a rod which had a uniform temperature previously, and then we keep ice cubes on both sides, and so the temperature starts to change at each and every point, and that temperature we need to say at a given time and at a given position. So you want to write what is uxt for a given x and given t. Okay, so the solution is like this. The heat equation is ut equal to c square uxx, and the conditions are like wave equations conditions. U0t is equal to 0, that means left hand is kept at the 0 degree, and ULT is equal to 0, that means right hand is also kept at 0 degree. And you know that the temperature will change with respect to time. So the case which you have to consider is k less than 0, because we have mentioned that when k is equal to 0, the state will be a steady state. Steady state means the temperature will not change with respect to time, and when k is positive, the temperature exponentially increases, and that practically cannot happen. So the remaining cases, the case when temperature changes with respect to time, and here you know that whenever you keep ice cube on both sides, the temperature of other points will change, and it changes with respect to time. So that's why you have to take the case k less than 0. So at that time we have found that the solution is uxt is equal to a cos alpha x plus b sin alpha x e raised to minus alpha square c square t, and you need to find what is a, what is b, what is alpha. Okay, c is a fixed constant. Okay, so here the three conditions that we can use are this: u at 0 comma t is equal to 0, u at l comma t is equal to 0, and u at x comma 0 is equal to u0. This is what we mean by the road is initially at a uniform temperature. That means at a time t equal to 0, every point x, at every point x the temperature is the same and it is u naught. So these three conditions we need to apply to find the constants a, b and alpha. So first use the condition that u at 0 comma t equal to 0. As in the wave equation case, you can see that this is equivalent to saying that x at 0 equal to 0, and the second condition is equivalent to saying that x at capital L is equal to 0. So once you apply x at 0 equal to 0, from here you can see that when you put x equal to 0 here, then the answer should be 0, right? So this must be equal to 0. So this uxt will become 0. So what you get is 0 is equal to a into cos alpha 0. Cos alpha 0 is 1, right? And b plus b into sin alpha 0, that is sin 0 is 0. So what you get is a into 1 e raised to minus alpha square c square t. That is 0 is equal to a into e raised to minus alpha square c square t. Then either a should be equal to 0 or e raised to minus alpha square c square t equal to 0. But e raised to value can never be equal to 0. For any real number, e raised to x can never be equal to 0. Okay, whatever be that x, positive or negative, it cannot be 0. That's why we have to take the case when only you can have the case when a is equal to 0. So your uxt will become 0 plus b sin alpha x into e raised to minus alpha square c square t, because you have already got a equal to 0 by taking the first condition. Now the second condition, that is ult equal to 0, gives you x at L equal to 0, or definitely you can substitute it in u itself. So if you substitute it here, you can see that 0 is equal to, when you put x equal to L, u value will become 0. So 0 is equal to b into sin alpha L into e raised to minus alpha square c square t, and there are three possibilities. Either b can be 0, or sin alpha L can be 0, or e raised to minus alpha square c square t can be 0. But this is not possible. E raised to minus alpha square c square t equal to 0 means it is not possible, because e raised to x can never be 0. Now if you assume that b equal to 0, already a equal to 0, now if b is also 0, then your u will become 0, right? So there will not be, it will be a dead case, that is the temperature at every point will be 0. So that case is uninteresting. That means you are not getting the fruitful solution in that case if you assume b equal to 0, because b equal to 0 implies u will be totally equal to 0. You will become the 0 function. That is not what we want. So the only option is sin alpha L must be equal to 0. Okay. And when does this sin alpha L equal to 0? When alpha equal to, remaining things are exactly in the same way that we dealt in the wave equation case. So alpha L should be equal to n pi, or alpha should be equal to n pi by L, where n can be 0, plus or minus 1, plus or minus 2, etc. But here you don't have to take the negative symbols, because your all the other constants are positive. So if you take n equal to negative value, then one of them must be negative. That is not happening. So you have to take positive constants only. So here u will become u of xt is equal to b sin alpha is now n pi by L, right? So b sin n pi by L x e raised to minus alpha square c square t, and so this, for each value of n you will get one solution. So you will get u0 t if you take n equal to 0, and u1 t, u1 x comma t if you take n equal to 1, and so on. So at each time you get different solutions. So I call the solutions as u0 xt, u1 xt, etc. In general un xt. And there this b also can change depending on the cases. If you take the first solution, there will be a constant. That constant will be we will call as b naught. Then b1, b2, b3, etc. Constants will change depending on the cases. So we have plenty of solution. In each solution there will be a constant, and those, it is not guaranteed that each constant will be the same. So we have to assume that they can be different. So that's how you get this. So you can write uxt is equal to this. And since there are infinitely many solutions, their infinite sum is also going to be a solution. So that will be the general solution. So uxt is equal to sigma n equal to 0 to infinity bn sin n pi x by L e raised to minus alpha square c square t is the solution. Okay. Now what is remaining to be found is, of course, this alpha also you can write it as n pi by L. Okay. I have not written it. Actually it is n pi by L. N square pi square by L square, you have to replace this alpha. So imposing that condition, the third condition, that was that initially the temperature at every point is equal to U naught. So that gives you, when T equal to 0, U value is equal to U naught. So you substitute T equal to 0 and take Ux0 as U naught. So U naught is equal to sigma Bn sin n pi by Lx into e raised to this T equal to 0, right? So e raised to 0. So that means this is equal to 1. This is 1. So what you get is U naught is equal to sigma n equal to 0 to infinity Bn sin n pi x by L, which is, when you write a function f of x equal to sigma n equal to 0 to infinity Bn sin n pi x by L, that means it is the Fourier sine series, half range sine series of the function f of x. Here f of x is U naught. So the coefficients Bn can be found using the Euler formula. Using the Fourier series theory, you can say that if you have a Fourier series of a function, the constants are going to be the expression given by Bn is equal to 2 by L integral 0 to L, whatever be the function. Here the function is U naught, right? So f of x means U naught into sin n pi x by L dx. Okay. So if you just integrate this, U naught is a constant. U naught will come out, and if you integrate this sin n pi x by L from 0 to L, you will get 2 into U naught by n pi into 1 minus minus 1 raised to n as the value for Bn. Okay. Now you substitute that Bn here in the solution. So that is the actual solution that you need. Okay. So now we have incorporated all the conditions. That is initially the temperature at every point is U naught, and the left hand point is at 0, right hand point is also at 0. So accumulating all this, you can write the final solution from here. So this is the final solution. Here Bn was pending. Bn can be found using Fourier series techniques, the theory of Fourier series, or by Euler formula. So you just replace that Bn by this expression, you get the answer. So this is the required solution. Okay. So it's very simple. So there is another case where the temperature at both ends are not 0. That's a different case that we will see later. Okay. Thank you.